Hey everyone, it's Josiah. I really want to talk about the extendr project today. So if you're an R programmer, you've probably heard about RCPP. RCPP is a seamless R and C++ integration, extending and growing our applications via an easy-to-use, robust, and performant C++ interface. All key R data types map naturally into key C++ data structures. So essentially what RCPP does is it lets you build R packages that call C++ code. And C++ is a lot faster than R. So that means by using RCPP, you can make your code a lot more performant. And there's also this modern day predecessor to it. So CPP11 it comes from the tidyverse team as an alternative to RCPP. They have some different views, different paradigm as they tend to have, because the tidyverse is an opinionated set of packages. And CPP11 also lets you interact with R objects using C++ code. What you can do is write C++ code and call it from R and interact with R objects and vice versa. And this is so powerful because it's really sped up how efficient R code is. We always hear like, oh, R is slow. That's a lie. Whoever tells you that is lying because they're just saying C++ and C is slow. It's no slower than Python or anything else, right? It's just dependent upon what package you're using and how it's written. Like CPP11 and RCPP, there is rextendr. Rextendr is the same idea, but for Rust. It's got a lot of cool functionality. It lets us use Rust code in R packages. It lets us use Rust code in R Markdown documents, which is actually, I haven't used it, but it sounds really cool. So rextendr is essentially like use this. Use this as a workflow package. It automates repetitive tasks that arise during project setup and development, both for R packages and non-packaged projects. Rextendr, while it does let us use Rust and R together, it acts actually more like use this. It really just builds the infrastructure to use Rust in an R package. The real powerhouse is extendr. And extendr is actually just a Rust library. This houses the conversions from R objects to Rust objects and vice versa. So that's what we're going to be using under the hood. So let's actually just get started and walk through how this actually works. To get started, let's go to RStudio. And we're going to use this, create package. We're going to call this dev. This is going to open up an R project for us. And then once that R project loads, we're going to use rextendr to use extendr. Just like use this did, it creates a bunch of files and folders for us. Notably, this src or source directory. If we pop that open, we see we have a bunch of files called makevars, entrypoint.c, and devwin.def. These files are kind of the powerhouse of the integration between Rust and R. So if you've used RCPP or CPP11, you know that inside of the source library, you should probably have CPP or .c files. That is a C++ or C file, which have function definitions and so on and so forth. But in order to use Rust, we handle this a little bit differently. So inside of this source folder, we have another folder called Rust. And inside of that Rust folder is a Rust library. So what's happened is we've had this source folder, and then there's a subdirectory called Rust, which contains a Rust library crate. So for every R package that is going to be using Rust, we necessarily create a Rust library. And inside of that, there's another source folder which has the Rust library definition. And this is what it looks like from inside of R. But RStudio isn't a Rust editor. As much as I love RStudio, it's not where I'm going to be writing my Rust code. To write my Rust code, I'm going to use VS Code. We have VS Code open. The next thing we want to do is we want to open the folder, and we're going to go to that folder we've created, this R package. We're going to open src, and then we're going to open Rust. Inside of this Rust folder is the Rust library that we're building. And the Rust analyzer, if you don't have that actually, go to extensions and install the Rust analyzer. So now we've opened this Rust library inside of VS Code. We're going to open lib.rs. And this lib.rs file defines the Rust package that we're building. Whatever we build or make available to this lib.rs file has the potential, doesn't mean it is automatically, but has the potential to be used by R. First thing is this use extendr API prelude wildcard. And if you're a Python programmer, or if you've ever used Python, this syntax, while it's kind of similar to writing library extendr API, it's more like in Python writing from matplotlib import star, which is going to import a bunch of functions, structs, and traits and other things that are going to be available for us in our use. Next, we have this function definition. We have a hello world function that returns a string slice, which states hello world. This is cool. Great, simple hello world function. What's really cool are these 3 lines above it. So in order for any function to be made available to R, it has to have this #extendr macro put up above it. And that essentially is a directive to the compiler that says, hey, this function is going to be made available to R. Great. And when we do that, we also have to include it under this extendr module. So here we're including fn hello world because this is a function called hello world. If it's included in this extendr module macro, that means it's going to be made available to our R package. But one other thing I wanted to note here, there are 3 forward slashes. A typical comment, as you might see here in Rust, has 2 forward slashes, but 3 indicates as a doc string. When we have this extendr macro on it, it looks for those 3 forward slashes and extracts those and parses them using Roxygen. So that means if you have this export inside of this, that function will then be exported in our namespace in the R side. And that's super, super, super powerful. So how do we actually use this hello world function? Well, to do that, we actually have to go back to RStudio. So one of the things you'll notice is that we have a lot of shifting around between VS Code and RStudio. Okay, inside of RStudio, what we're going to do is we're going to open up a new script and we're going to run rextendr : document. This is kind of like running DevTools document, but this is specific for Rust functions. So when we run this, it's generating extendr wrapper functions for the package dev. It's compiling and it's building. So right now we're going through the compilation process. It's done, and it wrote this wonderful man page. Didn't work. That's okay. We don't need to see it. But what's actually really cool is if we go inside of here, we open up our R folder and look at the extendr wrappers.r script. Inside of here, we now have this new function called hello world. And what it's doing is it's using this .call function to call a C library. So what happens when we compile this is all of our Rust code gets turned into C code, essentially, that can then be called from R. And that's cool. Now that we have this function, we're going to DevTools load all to make it available to us. And we can run hello world. What about a more realistic example? Let's hop back over to VS Code. Let's go through the example of having a function called add2. It's going to have 2 arguments, x and y. But we need to specify the types here. And before we kind of just start writing this function, it's really important to understand the data types in R that map to data types in Rust. Rust has so many different data types. For integers, right? Rust ints, they have I8, we have I16, we have I32, I64, we have U8, U16, U32, and U64. These are all the different types of integers that we can have in Rust. The I stands for assigned integer, meaning it can be a negative integer, like negative 10,000, whereas U is short for unsigned, means it cannot be negative. And in the R world, there's only one kind, I32. Integers in R are represented as 32-bit integers. There's no I8, there's no I16, there's no I64, and there's definitely not any unsigned integers. Okay. So now, what about other R types, right? We have R doubles. That's actually represented as a 64-bit float in Rust. And then we also have our character that's going to be represented by either a string in Rust or a str, string slice. So in this case, in our function definition for add2, what we're going to use are two F64s. And very simply, we can just add these two things together, x plus y. We can do cargo check to see if it compiles. It doesn't compile because it expected an empty result, which means I forgot to specify the output type. Rust cares a lot about types. For Rust, you have to specify specifically the type of each argument and the type of the output. There can be no deviation from it. It can't be like R, where depending on the inputs, you might get a data frame output, a list, a matrix, or anything else. We have to be very, very specific. We can check again. Now we get a warning because add2 is never used. Well, let's change that. Let's add this extendr macro on top of it, which means we want to make this available to R. In order to do that, we can check it and it's used. But just because we add extendr here doesn't mean it's going to be available to our R package later. In order to do that, we have to specify it inside of our extendr module. So here we add fn and then add 2. We save. We can just check again. Finish, no problems. Now we go back to RStudio. And now we're going to do these two things again. We document and we load all. Now we have this function add2. Takes two arguments. Let's do 3.0 and 0.14 to get pi. Well, what about the situation in which we have multiple values? Let's do 0.5, 10, 99, and 2.17. And we're gonna add negative 99 to these. Oh no. Input must be of length 1. Vector of length greater than 1 given. That's because F64 is called a scalar value. And scalar values mean it's just one element. In R, there is no such thing as a scalar value. As much as I wish there was, there isn't. And Rust kind of only really works in the concept of scalars. You can have collections of these scalars, which we're going to have to use. So unlike R, where if we have a double 1, double 2, or double 100, these are all the same type, right? Like if I look at type of, and then type of, these are all doubles, right? Like there's no deviation. Doesn't matter how long they are. They're the same thing. To Rust, you cannot have more than one element if it's an F64. So to handle this, what we can do is use a vector of F64. And this is just a collection where each element is an F64 object. And Rust isn't as friendly as R or Python, where we can't just say, okay, well, this is a vector of F64s. Let's just add another F64 to each element with this syntax here. It's just not going to work, right? We can check it. Oh no, you cannot add F64 to vec F64. Well, how do we get around that? We have to iterate. Everything in Rust really comes down to iterators. The way we do this is we take this X object, we turn it into an iterator, which means now this is an iterator and we're going to be able to do something to each element of it. And here we want to apply a map function to it. This is a lot like pers map, actually, or lambda functions in Python. The way this works is we create a closure, which is just specified by these two kind of straight bars. And then we provide another argument name. So there's a placeholder value. I like to call it xi because it is the ith element of x. And then we have an expression that follows our closure. So what are we going to do with this xi? Well, I want to add xi to y. I'm going to add these two F64s together. Well, after we've done this, we still have an iterator. And what we need to do next is collect it into something that's usable. So what we're going to do is take collect, and then we have to specify the type that we want this output to be, which is going to be a vector of F64. Boom. And then we add the type annotation, and then we add the parentheses at the end. All right, well, let's check the results. How does it look? Oh no. this function expected a f64 object, but it got a vector. Well, that's fine. We can just change this. Vec f64. Save it, check it, perfect. All right, well, now let's see if this actually works for us. Let's go to the R side, recompile. So running DevTools load all. So sometimes it hangs up, and if it happens to you, honestly, just interrupt it, press stop, and then build the package. So Command Shift B. I don't know why the build always works and the load all doesn't, but hey, it is what it is. All right, and then now we'll do Command Shift L to load it. Now let's check out add to. Add to works. That's super cool. If you know Rust, you know that these types, f64, aren't NA aware. There's no such thing as an NA value in Rust. So what we're going to do is we're going to write a function that's called add NA aware. It's going to take, instead of vec f64, it's going to take doubles. And we're going to leave y as f64 because we're fine with having it a value that we want to add. So doubles is extendr's way of representing a vector of f64s, but that can actually have missing values. Inside of a double are a bunch of scalars, and those scalars are called R floats. So if we go back to this, actually, there are these types, R ints, I32, and we have doubles that are f64, and we have characters. These also correspond to a type inside of extendr that is a scalar version of each of these. So for R ints, we have R int, obviously. Not obviously, actually. Then we also have R floats for f64s. And then here we have R string. And then for R logicals, which I seem to have omitted, we have R bool. And then in the Rust side, it's just bool. So yeah, we have these types, right? So a double is actually composed of multiple R floats. So we can just take this function signature and do something quite similar to what we have here. X into iter, we're going to map xi plus f64, f64y, and then we're going to collect into doubles this time. And since we want this to be made available to us inside of R, we add extendr, and then we add it to our extendr module. Add NA aware. We save, we check. Oh no, expected struct R float found f64. So what we can do instead is at the beginning of our function, we're going to say let y equal R float from y. So you can convert f64 objects into R floats by calling the from method from the R float struct. Okay, great. Now let's try compiling. Check, perfect, good. All right, let's go onto the R side. And then again, we're going to extend our document, recompile, load all. Now let's try add to with a bunch of NAs. Now we have an NA, because our float automatically knows how to handle missing values. There are some other things that we can do, right? We have doubles. Let's just do, let's create another function called fnchar2, where we take x, and then instead of doubles, we're going to use strings. So strings is this vector version of the rstr scalar. And then we're going to return integers, which is the vector version of the rint scalar. So x is going to be a series of strings. We're going to iterate over it. This is a super big pattern. We're going to map. We're going to apply a function to xi. And now what we're going to see is xi is a string. So now what we want to do is see the length of this. And this is actually a little bit more complicated. So we're going to wrap this into an expression block. So I'm going to say let n char equal to xi dot len. And what we're going to see from this analyzer is that this is a usize object. Usizes are like infinitely sized. Like there's no way to like exhaust a usize, and there's no corresponding value in R. So what we need to do here is let's convert this to an I32. We can just say nchar as I32. But that's still not an R int. What we need to do next is say R int from. Now, each element of our iterator is going to return an R int. Let's collect into integers. Perfect. Now that's going to give us what we want. We've defined the nchar2, but alas, we have to specify it in here. All right, now we can go back to, let's just double check. Finished, great. Let's go back to RStudio, document, load all, and let's do nchar2. Nchar2, let's pass in letters. So if you haven't seen letters, it's just the alphabet. Great. And they each get 1. Well, let's look at dplyr Star Wars. There's got to be, great. Inside of Star Wars, there is a name column. So let's just check it out. Name, nchar2, name. Boom, beautiful, brilliant. Now we have an nchar function, right? Cool. I'm sure you can think of more creative things to do than I can on the fly, but you can see how we can start to write these functions in a seemingly fairly easy way. Maybe I'll do another video on other more advanced things, but this is the bare bones. This is how you get started. And I really hope that this has been helpful for you to just say, okay, I know how to create an R package, how to add extendr to it, and then start writing some very simple functions. If you have any suggestions for what you might want to see instructionally for extendr, add a comment below and like it and subscribe it. All right, great. Thanks, y'all.